What if Earth isn't alone in its orbit? What if there's a second Earth, a hidden twin, following us around the sun, but always staying out of sight? It's not science fiction, it's a real possibility. Astronomers call them Trojan planets, and one might be orbiting the sun at the exact same speed as Earth, always just beyond our view. Sound impossible? Let's explore the science and the mystery. For generations, astronomers and dreamers alike have been captivated by the idea of a secret world, perfectly matched to our own, traveling the same cosmic highway, but always obscured by the sun's brilliant glare. The science behind this tantalizing mystery lies in the realm of orbital mechanics, specifically in the concept of Trojan planets and the curious gravitational dance that takes place at the so-called Lagrange points. To understand how a second Earth could exist undetected, we need to explore these special locations in space. Lagrange points are positions in a two-body system, like the Earth and the Sun, where the gravitational pull from both bodies precisely balances the orbital motion of a smaller object. Of the 5 Lagrange points, 2, known as L4 and L5, are particularly intriguing. They form an equilateral triangle with the Earth and the Sun, sitting 60 degrees ahead of and behind Earth in its orbit. Objects at these points are gravitationally stable, meaning that, in theory, a planet, asteroid, or even a vast cloud of dust could remain there, locked into a shared journey around the Sun. But could an entire planet, perhaps even a true Earth twin, be hiding at one of these cosmic way stations? The idea is more than just science fiction. It's grounded in real celestial mechanics and has inspired both theoretical studies and observational searches. In recent years, astronomers have made remarkable discoveries that shed light on this question, though the reality is more nuanced and perhaps even more fascinating than the notion of a hidden mirror world. If you feel this concept awe-inspiring so far, don't forget to like the video, share it with someone who loves space, and subscribe to the channel for more mind-bending science stories just like this one. We're just getting started. One of the most significant breakthroughs came in 2010, when astronomers detected the first known Earth-Trojan asteroid, designated 2010 TK7. This object, about 300 meters in diameter, was found lingering at the L4 point, 60 degrees almost ahead of Earth in its orbit. Its discovery marked the first direct evidence that our planet does, indeed, have companions sharing its orbital path, albeit not full-fledged planets, but sizable space rocks. The existence of 2010 TK7 was soon followed by another remarkable find. In December 2020, astronomers identified a second Earth Trojan, named 2020 XL5. This one is even larger, measuring approximately 1 kilometer across, and also occupies the L4 point. These discoveries were made possible by advances in astronomical technology and targeted observational campaigns. For instance, the orbit and size of 2020 XL5 were confirmed using the 4.1-meter SOAR telescope in Chile, which allowed astronomers to track its motion with great precision. The fact that we've found 2 such objects in recent years suggests that there could be more Earth Trojans, perhaps even larger ones, waiting to be discovered. But so far, every confirmed co-orbital companion has been an asteroid, not a planet. Why haven't we spotted anything bigger? The answer lies in the very nature of the Lagrange points themselves. From our vantage point on Earth, the L4 and L5 points appear near the Sun in the sky, making them extremely difficult to observe with ground-based telescopes. The glare of the Sun overwhelms faint objects, and even the most powerful instruments struggle to peer into these regions for long enough to detect anything substantial. It's as if nature has devised a cosmic blind spot, shielding whatever might lurk there from our prying eyes. Despite these challenges, scientists have not given up. The search for a true Earth Trojan planet continues, driven by both curiosity and cutting-edge technology. Theoretical models suggest that a planet-sized object could, in principle, remain stable at the L4 or L5 points for millions or even billions of years. However, such a body would likely have been detected through its gravitational effects on Earth and other planets, or through subtle signatures in the orbits of known asteroids. To date, no evidence has emerged to support the existence of a second Earth-sized planet sharing our orbit. Yet the story doesn't end there. The study of Trojan objects is entering a new era thanks to dedicated space missions and increasingly sophisticated sky surveys. NASA's Lucy spacecraft, for example, launched in October 2021 on a mission to explore the Trojan asteroids of Jupiter. While Lucy's primary targets are far from Earth, the mission is expected to yield insights into the behavior, composition, and origins of Trojan bodies in general, knowledge that could be applied to the search for hidden objects in our own planet's orbit. In addition, astronomers continue to refine their observational techniques, using both ground-based telescopes and instruments in space to scan the elusive regions near the Lagrange points. Advanced computer algorithms help sift through vast amounts of data, searching for the subtle movements that might indicate the presence of a Trojan object. These efforts have already borne fruit with the discovery of 2010 TK7 and 2020 XL5, and many scientists believe that further surprises may be in store. So, what do experts say about the possibility of an undiscovered mirror Earth? The consensus is that while it's a captivating idea, the evidence so far points towards smaller companions rather than a true twin planet. The gravitational stability of the L4 and L5 points is well understood, and objects placed there can, in theory, remain for long periods. However, the formation and retention of a second Earth-sized planet in such a position would require an extraordinary set of circumstances, one that likely would have left detectable traces elsewhere in the solar system. Moreover, our understanding of planetary formation suggests that the early solar system was a chaotic place, with massive collisions and gravitational interactions shaping the planets we see today. Any large body co-orbiting with Earth would almost certainly have been disturbed by these processes, either merging with our planet or being ejected from its stable perch. The fact that we observe only small Trojans supports this view and makes the existence of a hidden Earth twin increasingly unlikely. Yet science thrives on exploration and the willingness to challenge assumptions. The ongoing search for Earth Trojans, both asteroidal and hypothetical planetary, continues to push the boundaries of what we know about our immediate cosmic neighborhood. Each new discovery, like 2020 XL5, adds another piece to the puzzle, deepening our understanding of orbital dynamics and the subtle interplay of forces that govern our solar system. In the end, the idea of a second Earth, forever hidden at the edge of sunlight, remains a powerful symbol of the mysteries that still await us in space. Whether or not such a twin ever existed, the quest to find it has inspired generations of scientists and stargazers to look beyond the obvious, to seek out the unseen, and to imagine worlds yet undiscovered. As technology advances and our eyes on the cosmos grow sharper, who knows what secrets may still be waiting just out of sight, traveling the sun's endless path alongside our own blue planet. The search continues, and with every new observation, we come one step closer to unraveling the mysteries of the co-orbital world. Perhaps one day, future explorers will finally unveil what lies at Earth's cosmic shadow, whether it's another rocky companion, a cloud of primordial dust, or simply the enduring allure of the unknown. The universe is vast, and its secrets are many. For now, the possibility of a hidden Earth remains one of the most compelling mysteries in modern astronomy, inspiring us all to keep looking up and asking, what else is out there, just beyond the light?